Myself Nishad. In this session, we will discuss the complete concept of power and energy signal. This session is organized as first we will define power and energy of a signal. Then we will discuss the condition to check whether a signal is power signal or energy signal, and we will solve some of the important questions based on the latest GATE syllabus. X of t is said to be an energy signal if it is absolutely integrable. A signal is said to be absolutely integrable if we integrate the signal x of t. That is, if we are integrating the modulus of x of t from the limits of integration varies from minus infinity to infinity. That is integral minus infinity to infinity modulus of x of t dt, that is less than infinity, or this integral has a finite value. Then the signal is said to be an energy signal. And in the case of a discrete time signal x of n, the signal is said to be an energy signal if it is absolutely summable. Absolutely summable means if we vary the summation from minus infinity to infinity of modulus of x of n is less than infinity. That is, summation of n varies from minus infinity to infinity. Modulus of x of n, that is less than infinity. That means its value is a finite value. Then the signal is said to be an energy. Now the examples for energy signal is a pulse signal, either a square pulse or a rectangular pulse or a triangular pulse or any exponentially decaying signal. These all are examples for energy signal. The value of energy of all these signals is a finite, that is less than infinity. Now, what is a power signal? Any bounded signal of infinite duration can be called as a power signal. For example, a sine wave, that is x of t is equal to a sine omega t. So the maximum magnitude of the signal is a and the minimum magnitude is minus a. So the value of x of t is equal to a sine omega t is bounded between minus a and plus a. That means minus a less than or equal to a sine omega t less than or equal to plus a, and it have infinite duration. Then it is called a power signal. For a power signal, power is finite and energy is always infinite. And in the case of an energy signal, energy is finite and power is equal to 0. If any signal does not satisfy this condition, then it will be called as neither power nor energy signal. Suppose energy of a signal is equal to infinity and power is equal to infinity, then that signal is neither energy nor power signal. That is NENP, neither energy nor power signal. Suppose energy is finite and power is also finite, then what is the nature of that signal? This case also the signal is NENP, that is neither energy nor power signal. No signals can become both energy and power signal, and energy signal can never become a power signal, and a power signal can never become an energy signal. Okay. For a continuous time signal x of t, we define or we can find energy is equal to integral minus infinity to infinity modulus of x of t the whole square dt. That means we are integrating the square of the modulus of the signal from the limits of integration varies from minus infinity to plus infinity. That is also equal to limit t tends to infinity integral minus t to t modulus of x of t the whole square dt. If the value of this integral is less than infinity, that means the value of this integral is a finite value, then the continuous time signal is said to be an energy signal. Similarly, the discrete time signal x of n, the signal is said to be an energy signal if it is absolutely summable. That means summation n varies from minus infinity to plus infinity modulus of x of n the whole square, that is less than infinity, or the summation as a finite value, then the signal is said to be a energy signal. Or we can say limit n tends to infinity 1 divided by 2n plus 1. Summation n varies from minus infinity to plus infinity modulus of x of n the whole square, that is less than infinity, that is equal to a finite value, then the signal is an energy signal, where 2n plus 1 is the length of the signal. In the case of a discrete time signal, for the positive axis, we have n is equal to 1, 2, 3 up to infinity. And similarly, for the negative real axis, n varies from minus 1, minus 2, minus 3, minus 4 up to minus infinity. And n has a values, n is equal to 0 as one value. So total length of signal is 2 times capital N plus 1, that is 2n plus 1. Okay. Our question is, we want to find the elementary test signals such as unit impulse signal, unit step signal and unit ramp signal, whether it is an energy signal or a power signal. Now consider our unit impulse signal. Unit impulse signal del of t is equal to 0 if t not equal to 0, and integral 0 minus to 0 plus del of t dt is equal to 1. That is, the strength of the signal is equal to 1. Now, in the case of a discrete time unit impulse signal, del of n is equal to 1 if n is equal to 0 and is equal to 0 if n not is equal to 0. Now we want to check whether it is an energy signal or a power signal. Since an impulse signal is defined only at t is equal to 0 or n is equal to 0, and even though the signal is absolutely integrable in the case of a continuous unit impulse signal, and in the case of a discrete unit impulse signal or a unit sample, the signal is absolutely summable, but the signal never becomes 0. A signal is an energy signal if it is absolutely integral, and it will be 0, or the amplitude of the signal will be 0 at any instant of time. Then we can call the signal as an energy signal. In the case of a unit impulse signal, even though it is absolutely summable or absolutely integrable, it never becomes 0 for any instant of time. So it is neither energy signal nor power signal, that is NENP. Now consider a unit step signal. We know that u of t is equal to 1 for t greater than or equal to 0 in the case of a continuous time unit step signal. In the case of a discrete time signal, u of n is equal to 1 for n is equal to 0, 1, 2, 3 up to infinity. Since the value of the signal is not absolutely summable or not absolutely integrable, and the signal never becomes 0 at any instant of time, so a unit step signal is neither energy nor power signal. Now consider a unit ramp signal. A unit ramp signal is defined as R of t is equal to t for t greater than or equal to 0 and is equal to 0 for t less than 0. In the case of a discrete time signal, R of n, that is equal to n for n is equal to 0, 1, 2, 3 up to infinity. Now we want to check whether it is an energy signal or a power signal. This signal is not absolutely integrable or absolutely summable. As t tends to infinity, the value of signal approaches infinity. So it is not absolutely integrable. In the case of discrete signal, as n tends to infinity, the value of the signal tends to infinity or approaches infinity. So it is not absolutely summable. So a unit ramp signal is neither energy nor power signal. Or we can also find the energy and power of the signal. For a unit ramp signal, the energy is equal to infinity and power also is equal to infinity. Both energy and power are infinity. So also this is an NENP, that is neither energy nor power signal. We can do one problem. We want to check the energy and power of a signal. That is, a signal is x of t is equal to rect of t. Rect of t, that is RECT of t, is called a rect signal. This is defined for minus 1 by 2 to 1 by 2. That is, t varies from minus 1 by 2 to plus 1 by 2. The value of signal is equal to 1. That is, rect of t, that is equal to 1 for minus 1 by 2 less than or equal to t less than or equal to 1 by 2. We can find the energy of the signal by integrating minus 1 by 2 to 1 by 2 magnitude of x of t the whole square dt, or limit t tends to infinity integral minus 1 by 2 to 1 by 2 1 square dt. So the value of this integration is equal to 1. So the energy of this signal is 1 joule. Similarly, we can find the power associated with this signal. The power of the signal P, that is equal to limit t tends to infinity 1 by 2t integral minus 1 by 2 to 1 by 2 1 square dt, and we have already determined integral minus 1 by 2 to 1 by 2 1 square dt whose value is equal to 1. So limit t tends to infinity 1 by 2t multiplied by 1, that is equal to, when applying the limit, the value of t tends to infinity, the value of this limit is 1 divided by infinity, that is equal to 0. So energy is finite and power is equal to 0. So this is an energy signal. Now consider this question. The signal is defined for minus 2 to plus 2. The value of the signal is equal to 1 for a time duration minus 2 less than or equal to t less than minus 1. And from minus 1 to 1, the value of signal is equal to 2. And from 1 to 2, the value of signal is again become 1. Now we want to find whether the signal is energy signal or power signal. So the energy of the signal is equal to limit t tends to infinity integral minus 2 to minus 1. The value of the signal is 1. So 1 square dt plus integral minus 1 to plus 1. The value of signal is 2. So 2 square dt. That is integral minus 1 to 1 2 square dt plus integral 1 to 2 1 square dt. And we can find the value of this integral is equal to 10. That is a finite value. Energy is equal to finite. Now we can check the power of this signal. Power of the signal is limit t tends to infinity 1 by 2t. Integration, range of integration varies from minus 2 to 2. Now that is limit t tends to infinity 1 by 2t multiplied by integration of minus 2 to minus 1 1 square dt plus integral minus 1 to plus 1 2 square dt plus integral 1 to 2 1 square dt, and the value of this integral we already determined as 10. So limit t tends to infinity 10 divided by 2t, the value of this limit is equal to 0. Now energy is finite, that is equal to 10 joule, and power is equal to 0. So this signal is an energy signal. In the next session, we will do more problems from power and energy signal. Okay, thank you. Bye.